Hi everyone, welcome to the Nexus webinar. My name is Brittany Hines, Marketing Assistant here at HYPACK, and I will be your host for today's presentation. So for today's webinar, we are going to show you how to take aerial surveying and mapping to the next level with the Nexus. I would like to introduce to you the project lead for unmanned systems, Vijay Pradith, also known as V to many people in the industry. V worked as a physical scientist at NOAA Office of Coast Survey and was also involved with several maritime archaeology cruises as the chief mapping scientist. He has led many things, such as a sensor and technology evaluation related to hydrography and emergency response applications. He has also done hydrographic data processing improvements using high-performance computing systems. He brings extraordinary experience and expertise to our company, and we are so happy to have him here with us today to talk more about the Nexus 800. So I'm sure you all are very excited to hear more about this new system, so I'm going to turn over the presentation to the one and only V.
Well, thank you, Brittany, for that warm intro there. And hello, everyone, and thank you again for spending your precious time with us. I'm just going to go over a quick overview of what you're going to learn from this presentation. So I'm going to talk about essentially who we are, so who is HYPACK, the current debates on LIDAR or photogrammetry in the markets currently. HYPACK, I believe, has a solution where we say do both at the same time, and you'll see the tools to facilitate that process later. So some of HYPACK's value-added options there, so what we do, what we add, and how they provide that value to the work that you're doing. And next is why use HYPACK for aerial systems. Basically, what tools do we have that support the aerial industry? I'll talk about those two as well. And last thing is just how the Nexus helps you work. So who is HYPACK? So HYPACK's actually been around since about '84. Most of you probably are familiar with HYPACK's maritime roots. So we're on ships, we're on boats. More lately, we're on unmanned surface platforms too as well. But we started quickly realizing that a lot of these sensors are pretty much common, and they're common no matter what platform it's on. So it can be on again a ship or a boat or a car, or even now drones now. So we kind of make a little joke here, but whales can actually fly. So that's where our shift toward the air came from. So what the aerial industry, how they benefit from this is essentially we have 30+ years of sensor integration and expertise. So I will caveat that by saying we know these systems very well, and we know how they work. We know how they integrate too. On top of that, we have a very robust hardware sensor library too as well. We can essentially interface with over 400 things, and you name it, we probably actually talk to it, which is great. Any specific LIDAR, acoustic sensor, INS system as well, and any other piece of raw sensor data that you think that you have, you could potentially interface with HYPACK, and that is the value of HYPACK itself applied to this ecosystem. So this is an example here of essentially a potential pipeline for these aerial systems as well, and we present to you a end-to-end solution. And what this means is basically from start to finish, HYPACK is there every part of the way. So in the first, I'll start off from the left here and work right. So from the planning end of things, it's obviously when you start your project planning or your survey planning, you're going to want to know where you're working, what you're actually going to be doing, and what sensors you're going to use to do that work, right? So then you also tell HYPACK in this stage of the phase here is what sensors you have connected to your platform and how they're going to be acquired. That transitions over to the acquisition side of things, and basically this is where you tell HYPACK what you're going to collect and that you are going to collect this data, and this is essentially where all the data is fused, combined, and integrated into one file. The next stage is the post-processing phase of things, and this is where you take that one file and you bring it through our pipeline, and we offer you some tools to actually edit the actual data, filter it, load any perspective correctors of some sort in there too as well, and then you push this data over to the analysis phase where you can start to run your performance metrics, stats, and so on and so forth. And to the final stage is where you actually turn the data into something. So into some kind of product, be it an XYZ file, a CAD file, a GIS file, a LAS file, and so on. So I'm going to take a quick little sidebar here. It's one of the questions that I get asked quite a bit in terms of, well, what makes your solution different than what's actually out there? One of the questions I'll always come back with is, what is your time worth, right? So this is exemplified in the photogrammetry world in terms of how that process is. So in that world, you need to go out, you need to do a whole bunch of pre-planning, you need to lay out a bunch of ground control points to it as well, actually mark where those points are, occupy the actual points, collect the actual data, and then you have to post-process, right? And for most of you in this industry right now, you know that sometimes it could be a very time-consuming thing. Okay, so in this next slide here, this slide really exemplifies the current state of the industry, right? So you can offer your service, and if you really think about it, if you can offer a couple of options, you have only 3 choices, and out of those 3 choices, you can only pick 2 at any time. So first example here is that you can have a service or a solution that's actually good and cheap, but won't be fast. You can have a second option where the solution is fast and good, probably won't be cheap. And the third option here is cheap and fast, probably won't be good. So the Nexus solution that we offer, we think probably falls into the fast and good and won't be cheap category, but I'll caveat that by saying you get what you pay for. So introducing the Nexus 800, and the underlying design philosophy of the craft itself is about time, or more importantly, saving time. And we do this through the several tools that we have within HYPACK in terms of the real-time fusion of the actual data, the streamlined process from the raw acquisition of the data to the post-processing phase of things. But this platform or this solution was created such that time is your key factor. So if you need something quick, if you need something, and if time is your main priority for whatever job you're actually doing, the Nexus is for you. So what can the Nexus do that other things can't, right? So HYPACK specifically on the software end of things is very much real-time focused. So any real-time acquisition of the actual data, we also provide you with the output, feedback in terms of how things are working, how the sensors are performing. More importantly, we also give you the pipeline to go from the raw process to the actual post-process as well to be able to actually push something out afterwards. The next bullet there is true multi-sensor support. What does that actually mean? So that means in our for HYPACK, for our philosophy is that we treat the Nexus as a platform, and the platform itself just carries sensors. So theoretically, in the future, if some other whiz-bang sensor comes out, you can actually apply that new sensor on the same platform. So what that means, that segues to the next bullet there, is that it allows you a facility to actually upgrade your sensors without having to worry about the actual platform. Again, just to reiterate, the full software pipeline from start to finish, so being able to collect your, being able to plan your data, collect your data, process, and push it out to a product. And the most important point in my mind is the last bullet here, and that's the support. So our after-sales support is great, and I will basically say that it is spectacular. So the customer can always expect a great after-sales support in terms of if there's any issues with the craft or any issues with the actual data, our support team will be there to help you. This is a deeper dive into the actual pipeline itself, to kind of the inner workings of HYPACK, if you will. On the left side of the screen here, what you're seeing is essentially the raw stream from the actual sensors coming into HYPACK. So when they're collected, when they're actually fused, when they're actually time-stamped, and what it makes is essentially a raw file. And that raw file then gets pushed over, so that's the arrow there, going over to the right side of the slide. That then leads to the data editing portion of things, right? So where you take the actual data and you do something with it. So you edit it, you correct it, you proof it. This is where this actually stage happens here. But again, it's toward the idea that you're one pipeline process where you're turning that raw data into information as quickly as you can. So the Nexus 800 offers a what we call a multi-sensor payload. So essentially, the idea again is that you, the operator, having to devote your time out there to actually fly. And our philosophy is it benefits everyone if you're able to collect more than one thing, right, or more than one set of data on any flight here. So the craft itself carries several tools on board the actual platform, and these tools include a full version of HYPACK and HySuite. So that is actually contained locally on the craft itself on the onboard high performance PC on board, a RGB camera, a thermal camera. This is actually new, so we are actually proud to announce that we are now including the FLIR View Pro R in all installs of the Nexus 800. It also includes a survey-grade INS system as well, the laser scanner, of course, and again, all of these are coupled onto the actual platform itself. So to dive into some more further detail, and some of the questions I'll get asked too is, well, how did you pick out the actual pieces here, and why did you choose certain components to integrate with this platform? And it simply comes down to an engineering term called SWaP-C. And what SWaP-C stands for is actually size, weight, and power, and then the C is cost. And basically, in this instance, for this platform, we looked to maximize the value of the actual the platform, so the performance of the platform, but more importantly, making sure that we ensure that our customers and users and operators get the best bang for their buck. And again, you can be rest assured that any other future sensor out there will probably be supported on this platform. Some additional specs on the UAV itself. It is considered a heavy lift platform. 8 pounds on the current payload if you use the camera. The thermal imagery is also included too as well. The max capacity of the payload is approximately 11 pounds. It does have the functionality to do auto takeoff and landing, meaning basically if you plan out a flight plan, you tell it essentially how high it has to go, how fast, and how it turns, and you hit go, and it actually takes off, flies, comes back again, and then lands. Additionally, there's about a 10 to 15 minute flight time, 12-minute average, and this really is dependent on how fast you're flying, what you're doing, where you're going, so on and so forth. The additional point on the bottom, subsequent of that, is that you can actually hot swap the power. So this means you can go out, you can go fly, basically come back in again, you can land. You do not need to turn anything off. You can keep all of your hardware on, and basically you just hot swap in between. There's actually 2 battery banks on the craft, and you just swap out each spent one with a fresh one, and that allows the craft to actually be on at all times. So we think that's actually nice. So one of the functionalities of this, or one of the operational paradigms here, is that you would fly, come back in again, leave everything on, swap out batteries, and keep flying, and just keep the other spent ones on the charger and just keep on charging. And as an example of this, this is a 40,000 square meter area right here, covered essentially in about 5 minutes at about 4 meters per second, and flying at a height about 4 meters above the ground. This is an example of what the operator would see in real time from the ground station computer itself. So this is one of the power and strengths of HYPACK, is that the operator can actually QC and QA in real time basically what the actual craft is also collecting and seeing too as well. So this is definitely helpful. Again, so if there's a issue for some reason with the craft itself, or an issue with the actual sensor, the operator can see it in real time, and they can interact and interdict if need be. and they can be rest assured that the quality of the data will always be preserved at all times. There's a industrial flight controller included too as well with the platform. Again, this is the module that allows for the auto takeoff, auto landing, return to home, but also it allows the operator to manually taking control over the craft if they have to, if something happens and if they need to assume man control. Okay, so this could be, essentially this platform was chosen for its ability to handle robust winds. So in this video, this example, this was a 20-knot steady wind with a 30-knot gust. And as you saw in the video, the craft was quite capable and was able to handle it without any problems. So next slide, I'm going to start talking about essentially some of the other tools that we have in HYPACK, and specifically how they relate to the surveying and engineering world. So one of the questions is, how do we get access to the data, right? So I'll start from the left here and work toward the right here. So the craft has a real-time 5 gig high-speed link in between the ground station computer and the UAV. And basically one of the ways that you can get access to it is that through that high-speed link, you can actually transmit data from the craft itself down to the actual ground. Data integrity is secured because there is the link is encrypted in between. The next option, if you move over toward the right here, is that you could just simply wait for the craft to fly its mission, come back down again, and just take a flash drive, plug it in toward the back of the USB supply port, download your data, and just keep on working that way. And the third option is actually very interesting as well, is because the craft itself can be put online. So by that I mean the ground station, if you have a hotspot of some sort, if your cell phone can actually act as a hotspot, or you have access to Wi-Fi somewhere, the craft is linked such that the craft becomes online too as well. So you can actually drop in a client like Box or Dropbox onto the craft itself, and you can have HYPACK copy the data over there. And as the data is actually being copied over, the drive client will then transmit that data to anyone that has access to that folder, and literally anywhere in the world, the person who has access to that folder will have access to that data. So the other question I always get to is, how do I get RTK here, right? So how do I improve the INS solution that I'm always seeing a RTK fixed int solution in the INS sensor? Two ways. One of the ways is, again, if your ground station is online, the craft is online, and you can actually access a NTRIP-based service. So basically that is a internet-based RTK correction service that we can grab, and we can take that stream, and that stream will get input directly into the INS on board the actual Nexus, and those corrections are provided in real time. Method two is that there's a separate RF modem attached to the Nexus as well. So this would apply to people that work in cellular poor areas where you might not have a cell signal, but you do have access to a GPS base station. So as long as your GPS base station is capable of broadcasting the corrector over RF, you can actually transmit those correctors to the actual craft, again, to the onboard RF radio modem on the craft. The craft will receive it, and it'll output that corrector directly into the INS again for your RTK fixed solution. So I'm going to continue on now. These next subsequent slides actually detail some of the examples that we collected with the system. This first one here actually details an example here. The first upper half of the slide details a hillside area there with a parking lot on the bottom there, and that is actually being colored based on elevation, right? So you can see the actual fine detail of the hillside, the trees and the shrubs, some building structure there on the bottom, to even some parking lot features too on the bottom of the screen. toward the bottom of the slide, the coloring is slightly changed, right? So what you're seeing there is part of the power of HYPACK 2 as well. And HYPACK can also paint your actual point cloud based on the RGB color. So what this means is that I can take any spatially geo-reference imagery of any sort. I can essentially put a footprint of it over the actual point cloud, and it'll recolor it. So it won't actually drape the actual data, but it'll actually recolor based on your actual LIDAR data. Next example here is actually from one of our customers right now who are actually operating with the actual system currently, and you can see the level of detail that they were attaining with the actual system. So the top upper portion again is of a work site that is colored by elevation, and they also leverage the power of HYPACK. So on the bottom portion of the slide, you'll see essentially a spatial image that was actually recoloring the actual point cloud based on RGB, and the results here are quite spectacular. So the next slides detail the performance of the actual system. So we do have a side-by-side comparison of the system here. So in this case, we have a reference data set based on a topographic scanner. So basically, we took a ground-based scanner and compared it to what our UEV collected here. And what you're seeing here is green is what reflects the base set, and the red reflects what was collected from the UAV. And the comparison here basically creates the actual point cloud, and we take a subset of that point cloud. We do a node-by-node comparison within HYPACK, and again, HYPACK has the tools for all this as well. And we essentially take a 10-to-10 surface comparison in between the two to find out what the vertical distance offset is between both surfaces. This further details the actual process. So the upper left-hand corner is the tin of the reference data set. The lower left-hand corner is the tin of the Nexus data. And when you take a surface-to-surface comparison, what you get is that surface right in the center there. And what's interesting about this is that purple color there is basically that there is a drastic change in the actual difference between surfaces. And why that could be explained is basically you're shooting the ground-based scanner from a different angle from the Nexus, which is shooting up and above, right? So in this case, with the Nexus, we're actually collecting more data that the land-based scanner couldn't see. So for an apples-to-apples comparison of the performance, I actually just took a subset of this within that red box there, and the resultant surface is what you see on the right-hand most side, and that is what we did the performance comparison on. And these are the results here. So we see that we get about the 0.18 foot difference in between the topographic scanner and the Nexus itself. Equates about 2.16 inches or about 5.5 centimeters as well. And yeah, and this is, I should also caveat this by saying that this was the Nexus and the topographic scanner all shared the same RTK base station. I'm going to continue on by talking about the other HYPACK tools or in the software within Ford UAVs and how they apply. So the first one here is for any HYPACK customer who is fully aware of HYPACK and its options that we actually offer, background charts is one, right? So being able to plan your actual survey, where you're working, side of things, this applies as well. So if you're already an FAA certified pilot, you already know that one of the first things that you have to do is that you have to check your area, right? So where are you working? What are you going to be doing? Where are you going to be flying? Can you fly? And if you can fly, are there any restrictions associated with that area? So this next slide here shows some more of the post-processing tools available within the Excel software. So this is a post-processing filter that one can also run to as well. So for some applications where people are only interested in the bare earth, right? So if you just want to know, I just want to see how the slope of the area is, general topographic features, I don't want trees, I don't want shrubs, just show me what the bare earth actually looks like. We have post-processing tools that can facilitate that data. Additionally, one of the other powerful tools within HYPACK is as well is being able to correlate the data. Again, don't forget all of the data, because it's being controlled, it's being timestamped within HYPACK. We know exactly when things were done, when things happened, and how it happened actually. So in this example here, we are correlating the LIDAR point cloud here, and I can click on anywhere within the actual point cloud, and within that point cloud, I can actually see the corresponding image that was taken through the actual onboard camera. So in this case here, I can choose, if I see a feature, if I'm not too sure, I can click on the point cloud and it'll bring up the picture and it'll say, oh look, it's a shrub. The additional functionality of HYPACK as well is that we also will geotag the pictures based on the actual point cloud. And we both have, we have the functionality to both geotag the image in post-processing, or as well as real-time depending on the actual sensor as well. So that does not limit the operator from being able to process their imagery in any third-party package. This is an example of some of the products that we can also push out from HYPACK. The left side here, one of the formats that you can export out is a web cloud format, and basically it's a portable web cloud that we call WebGL. And what this means is that it's essentially supposed to exporting out a file like an XYZ or a LAS file. You can actually export this WebGL file, put it on a thumb drive, give it to your customer, and they can open up in any internet browser, so be it Internet Explorer, Chrome, Safari, what have you, and they themselves can actually interact with the actual data through the actual internet browser there. The other option too as well is that we have a number of template reporting tools as well. So this example here on the right side of what's actually possible with HYPACK. This next slide also again shows an example of point cloud being colored by elevation here. And again, the power of context here. So just being able to recolor the actual point cloud based on a RGB color. So you get the best of both worlds here. So this is a hybrid solution that I believe differs with quite a bit with others in the actual industry. So what we do is that we take the LIDAR point cloud as our base, as our foundation, if you will, and we recolor everything based off of that. So another application would be if you're flying thermal and you want to have a thermal point cloud of some sort. One could actually collect the data with their LIDAR data as the foundation and then be able to color your point cloud based on that thermal data again. Again, for us, it's a common data set, just having different looks within that same product. And lastly, this is another option too as well in terms of, well, what else can I do with an actual point cloud? And again, HYPACK has tools as well. So there's more tools so we can take the point cloud and we can actually grid it. So in this case, this is of a module within HYPACK called 3D Mesh, and we're taking the actual point cloud and gridding the point cloud based on some parameters again. But again, we do not limit people in terms of what they can do, but this is just to show the people the functionality and what is possible with our software. And with that, I'm going to push it off to Brittany.
Thank you, V. What a great presentation. We are so excited about this new system and hope this gave everyone a better understanding on how the Nexus provides a seamless solution for aerial mission planning, data acquisition, post-processing, and product creation. Now, there were a lot of questions that came in, so let's go ahead and start the Q&A section of the webinar. We hope that you stick around for this section, but if you're unable to, we want to thank you for joining us today, and we hope to connect with you in the near future about the Nexus.
Well, great. Well, thank you again, everyone. I appreciate your time, and let's see here. So one of the first questions I'm seeing here is, what training is included with the system? Great question. So HYPACK's philosophy on training is that, yes, we will train you on the system, and with the system itself, you get 3 days of flight training with the system, and you also get a separate 3-day HYPACK training as well. And the idea for us is to be able to get the customer on the ground running as soon as possible. So we essentially handhold you through the whole process in terms of how the system itself operates, how it flies, all the way through the actual software side of things. So how the sensors are actually integrated, how you collect the actual data, how you process the actual data, and then more importantly, how you get something out of the actual data too as well. So thank you for that question. Next question is, what is included with the system? And we like to think of the system as what we call RTF, that is ready to fly. So anything and everything needed to actually hit the ground running again, we think is included with the system. So for example, we even include an actual iPad there too. So an iPad, a Panasonic Toughbook, all the sensors, all the hardware, and of course all the actual software. And it all comes with all the flight cases as well. So there's 2 cases. One of the cases holds the actual UAV, and the other case holds the actual power supply, so the chargers and the battery set and so on and so forth. But again, everything that we think that you need to hit the ground running and operating with your system, we believe that it includes. And if it does not include it, then obviously we're open. So if there's something that you feel should be included, please let us know, and we're open to. We're all open ears here. And let's see. Being prodded by Brittany, looks like we're running out of time, so I'll have time for one more question here. And the question is asking, what is the expected data coverage of the UAV? So great question, and I'll flip back to the example where we talked about covering 40,000 square meters example there. And in that example, I had about, we were flying about a speed of 4 meters per second at about 40 meters off the ground. And we probably collected, actually I should say, I know we collected over, it's about 250 points per square meter. Obviously that is going to differ based on how fast or slower that you fly. So in this instance here, if using 4 meters per second as your benchmark, which is about 9 miles per hour, if you fly slower, that 250 square meter coverage, points coverage there will actually increase. And vice versa, if you go faster, that number will actually drop. And I think off the top of my head, if you go perhaps 1 meter per second up, 5 meters per second, up to 12 miles per hour, that number drops to about 220 points per second. So with that, I'll pass it back to Brittany.
Okay, everyone, we are unfortunately out of time, so we're going to wrap it up. We want to thank you all for your participation and hope you all enjoyed the webinar today. Everyone will get a copy of this presentation, and we will also get in touch with anyone who had unanswered questions over the next week or so. Also, please don't hesitate to contact us. We want to hear from you. So we can be reached at unmanned@hypack.com. And don't forget to check us out on Facebook, Twitter, and LinkedIn for upcoming news and updates. We hope to talk to you soon, and have a great rest of the day.